Thanks for joining us. My name's Scott Sumner. I'm the CMO at Kadiska, and I'll be joined here today by Terry Nuttermans, who's our Chief Product Officer. And we hope to illuminate some of the problems that you guys have with Teams and give you an actionable path to solving those in this webinar today. I'm going to take you through a little bit of the background of Teams, and then we'll hop into live diagnostics of Teams issues and why they happen and how you can fix them. Is Teams actually one of the single biggest issues you guys have? We've had a lot of communication online on LinkedIn, and I've actually had this conversation with one of the executives at Salesforce. This is not something you can make up, right? And he said, we actually paid $27 billion to eliminate our Teams problems. Now, that's probably exceptional, and it's a little bit unusual. That's because, of course, that they bought Slack just a little while back, and they've actually replaced Teams completely by using Slack conferencing instead. But for most of us who don't have an extra $28 billion lying around to solve this problem, or don't want to change all of our infrastructure, there is definitely a better way to solve these problems. So when we talk to IT operations guys, network operations people at large enterprises, they tell us this is their single biggest performance issue. And of course, working from home and a lot of remote working, hybrid working is causing this problem to become much more critical for the enterprise. When you look at Down Detector and people report in the end what the root cause of the problem was, it's more than 3/4 of the problems with Microsoft Teams call quality, connectivity issues come from the network side of things, which is not a big surprise, but actually with Microsoft Teams, the way they actually demand the network to perform is extremely different actually than some of the other conferencing solutions. And this is actually what creates the issue and causes Teams to behave in some cases quite a bit worse than other conferencing solutions. When you look at the majority of these issues coming from the network side, the question is, why is the architecture of the way Teams is designed on a specific kind of network behavior to make things work well? So we'll take a look at that live in a little bit. But I want to show you that behind Teams, whether you're logging in through a web client or the desktop client, there's a lot of different host names and servers behind Microsoft Teams session. It's not just teams.live.com or one server. There's all of these different servers, and there's many more than this. There's more like 14 different kinds of servers you have to connect to join, to stream the chat side, to do the whiteboard. But the most important from your user perspective is the media servers. And the media servers are the ones that are really responsible for the streaming of the video and sharing your screens between participants, as well as like the audio. So the media servers are the critical component that once the team session is up and running can define pretty much everything that's going to happen to you, and probably has in your experience with Microsoft Teams. So call drops, call quality issues, one-way audio, all the things that can go wrong. This is all responsible for the media servers' performance. And I'm not actually sure that it was Bill Gates who said this, but it could have been, because this is a really important piece of information for IT guys. If you want Teams to perform well, you have to really connect as quickly as possible to the Microsoft core network. And the round trip latency here between yourself and these media servers needs to be 100 milliseconds or less, or as Bill is saying here, the Teams calls are going to suck. There's a lot of reasons why this latency causes an issue, but it's something you see quite often, and it's particularly acute in Microsoft Teams connectivity. And that's because the Microsoft media server architecture is different than you get on other conferencing solutions. They have media servers all over the world. There's one near you for sure. And if you're having a good Teams call, it's because you're close to your server that you're connecting to. But when you're working on a call that has people across multiple continents, sometimes things can go really bad. And that's because all the users on a single Teams call have to join the same media server. So unlike if you're looking at, say, Google Meet or WebEx, where you join the closest media server and it allows you to then stream between them, all the Teams call participants have to join the same media server. And how does Microsoft decide where your media server will be that's going to host your call? It's actually almost random. It's based on wherever the person is who joins the call first. That you've read that right. If one person joins from a remote location like Australia, everybody else on the Teams call has to connect through the same media server in Australia. And when you're talking about these latency issues of 100 millisecond, you've just broken the call. And of course, we all have experience with this. And sometimes you can't control this. What if the person's an external person joining from a different company and you're having a call with someone in India or Latin America or anywhere that's outside your region? you're going to be suffering from this quite badly. So we know from the stats before that if Teams issues happen, it's most likely the network, and this architecture choice that Microsoft has made almost guarantees you're going to see this in international calls. But the problem in this scenario, in terms of debugging it, troubleshooting it, trying to fix it, is that there's not just one network between you and these media servers, right? There's a really complex matrix of connections. When you look at people working from home right now, Gartner just reported a couple of weeks ago that 58% of employees spend predominantly working in jobs that support that. Very highly distributed sites. So if you're at a retail location or manufacturing site or headquarters, all over the place, and you have a lot of different connections that are now brokered through things like SASE or Cloud Access Service Broker, the CASB, VPNs, there's SD-WANs, there's cloud networks out there, there's private connections, and there's CDN streaming traffic as well. So you end up in a situation where this hybrid connectivity matrix is very difficult to understand exactly where the problems that can cause long latency originate from. So that's what Kadiska does, and we'll show you that in a few seconds. Set up test stations around the world that are managed by us, and anyone can use those to test out connectivity from all the main ISPs and countries in the world. And also you can test from your own sites by spinning up just a simple container-based tracer station. And from there, you can understand the absolute route between yourself and Teams server or any other SaaS or web-based application. And you can see all different service providers in between you and the Teams server, and also which one is breaking the call. And you'd be surprised how you get redirected all over the place, depending on your ISP or your providers or your SD-WAN's configuration. So this is what we're going to take a look at, and I'm going to pass this on to Thierry and look at how to find problems with Teams and how to fix it using our application.
Thanks, Scott. I will try to give a sense of what we can do in just 10 minutes. As a short wrap-up of what Scott explained before showing you live, there are two really important things you want to monitor when dealing with Microsoft Teams connectivity performance. First, you want to monitor the network latency between your users and Microsoft media servers they may connect to, as you should remain below 100 milliseconds. Next, to achieve this, Microsoft recommends to connect as quickly as possible to its backbone, which is optimized to transport streaming traffic. So this is another aspect you want to measure and understand. How do your users connect to the Microsoft backbone through their local operator? And you have to keep one important aspect in mind, which is quite specific to Microsoft compared to other players. Like Scott already mentioned, all attendees will connect to the same media server, and the first attendee to join the session will determine the choice of the server. Let's take now a first example. So for this example, let's assume that Scott and I have a session together. Scott resides in Canada and I'm living in Belgium. So by now you know that we both have to connect to the same Microsoft media server. So in this case, let's assume that Scott is the first to connect to the Microsoft Teams session. It means that Scott will probably connect to the closest Microsoft media server. And this is exactly what is shown here. So this dashboard shows the situation of Scott connecting from Montreal to different Microsoft media servers potentially. So we have here a panel of 14 media servers we monitor for the purpose of this demo. And you see here from the list that the smallest round trip time Scott will have is when he will connect to the Microsoft media server located in USA here. So this is this one, 31 milliseconds when connecting to an East Coast US-based Microsoft media server. But what about me? What will be the situation? Because I will have to connect to the same server. So I will change my viewing angle by choosing another source. So I will now be focusing on Belgium. This is where I live. And obviously my situation is different from the situation of Scott, because I'm located in Belgium, so I better connect to media servers located in Europe. But in this case, I will have to connect to this one. And that this one has a round trip time of 101 milliseconds, which is really at the limit of the recommended value by Microsoft. But it's not so bad, because don't forget that the traffic will have to cross the ocean between Belgium and the United States. So I can quickly understand why the situation is not so bad by going to the past performance view. The past performance view shows me all the network traffic paths between my location and the Microsoft Media servers in the US. And I can understand why the network latency is not so bad in my case. Because remember the recommendation from Microsoft, which is to peer to connect as quickly as possible to its backbone. And this is exactly what happens here. I'm connected on my local Proximus ISP network, which peers directly with the Microsoft backbone, even here in Belgium, way before crossing the ocean. And I can check that by highlighting the delays. And you see here most of the delays are within the Microsoft backbone. This is where the traffic has to cross the ocean. And this is why here I have a not so bad experience. Let's now take another example and let's focus on a user who is located in Argentina, for example. So let's focus on Argentina and let's have a look at the user situation. So as expected, when you are located in Argentina, you better connect to the closest Microsoft Media server, which is located in Brazil. But in this case, that the round trip is quite significant, is 57 milliseconds average, which you can argue it's quite a long time for a connection between Argentina and Brazil. So let's have a look of what happened from a network connectivity and network path point of view. I simply select the media server from Brazil, and again I go to the past performance view so that I will discover all the network paths that relate to this connection. And here you see in fact what happened. The users in Argentina are connected locally on the level 3 network backbone on the autonomous system 3549 before reaching another autonomous system, which is the 3356 from the same level 3 communications operator. Then finally before reaching the Microsoft backbone. And that in fact traversing the whole level 3 communications networks before reaching Microsoft Corporation caused a lot of delays. I can check that by highlighting the delays here, and you see indeed that most of the delays are introduced when the traffic is traversing the level 3 communication backbone. So one of my conclusions as an organization, if I have a lot of users located in Argentina using the Microsoft Teams platform, I should potentially better use an alternative local operator to connect my users to the Microsoft backbone more efficiently. The very last thing I want to show you is how you can also use the Kadiska Watcher technology in a context of network connectivity performance monitoring. The Watcher provides performance metrics directly from the user's browser. The experience of a user when dealing with Microsoft Teams does not start when being in a session. It starts by joining a session, which involves performing API calls that we are able to identify and analyze from a performance standpoint. So let's take an example here. So I will go to the Watcher, one of the Watcher monitoring dashboards, and I will select a lot more data here from the past. So I will take up to August, for example. Okay, and let's focus on the Microsoft Teams applications. And more specifically, I do want to filter on all joining events. So when users join Microsoft Teams sessions. So for that, I can simply here filter on join events. Okay, so I do not have time to go into all the details of the different metrics we provide, but what I want to show you is how we can easily identify the users and their respective locations. So for example, we make the distinction between remote users typically connecting from home. We can identify automatically on which ISPs they are locally connected, and we can also locate them by country, region, city, continent. And then we can distinguish these remote users with the on-site users that are connected from corporate sites. And here you have always for each section here, you see that provide the main performance drivers for the application. And you see the yellow part, which is related to the network performances. So I can tell you that joining a Microsoft Teams session for users connected to the Proximus network was quite a problem from a network setup point of view. It took nearly 400 milliseconds to initiate a session to join a Microsoft Teams session when a user was connected to Proximus network. Okay, so here I can easily identify who was impacted by simply filtering on the Proximus ISP name, so that I can see that it was me, in fact, who was impacted. Then I'm probably interested in knowing more about the Proximus ISP network performances in general. For that, I can navigate to the network dashboard and get rid of some filters to have an overview of how Proximus behave over time in terms of DNS resolution time, connectivity time, and TLS handshake time. You can easily benchmark Proximus, how Proximus behaves compared to other ISPs, and you can, for example, easily identify the users that are connected on this Proximus local ISP. So I see most of the users are connecting from Brussels and from Liège, for example. But you see that 3 users connected from Sint-Juste-Node on the Proximus local operator did experience a very bad TLS handshake setup time. So that here I can easily focus on this location and then, for example, identify the application what was degraded. And in this case, the users did have some TLS handshake problems when connecting to the Kadiska website. And by the way, you can see the impact from a loading point of view, for example, the impact of the bad network setup has had on this user.
Thanks for everybody for watching. And I just wanted to let you know that if you're interested in trying to solve your own Teams issues, we're offering a free trial. So Kadiska is very easy to spin up. It's a software as a service, so you can deploy it almost instantly to trace out to your different sites and from our different test stations around the world to see how people in your company are experiencing Teams and what the problems might be. So if you fill in the form at learn.kadiska.com/try, then we'll spin up an instance for you and we can give you a quick tutorial one-on-one to get you set up and get started with that. Let us know.